This is problem 8-56 from section 8.1.3. Write a polynomial equation for a graph that passes through the point -1, 60 and has three x-intercepts, -4, 1, and 3. So we're going to start by writing an equation in terms of the x-intercepts. So we've been doing that. We say like the opposite of it. So I'm going to say x instead of -4, it has to be +4. Because if I plug in y equals 0, I need to get out x equals -4. So that's why it's opposite. And then instead of x minus 1, x minus 3, because it's opposite. But what we learned a little bit ago in class is now I need to have a stretch factor possibly. So what we're going to do is have an a in the front, and we're going to plug in this point for x and y. So I'm going to say 60 equals this with -1, -1, -1. So really I'm going to have 60 equals a times 3 times -2 times -4. Okay? So when I multiply those together, I'll have 60 equals a times +24. To solve for a, I divide both sides by 24. I'm going to get 2.5. A is 2.5, or my stretch factor is 2.5. So my final equation, don't just have this be the answer. Your equation was all the stuff with the x-intercepts, but now we just have a 2.5 in front. Let's see, what were they again? I can't remember. X plus 4, x minus 1, x minus 3. We know this is going to be a cubic equation, or cubic function, and there's nothing that bounces. It's a degree 3. It has a stretch factor, what we had to find, of 2.5. So here's the equation for a polynomial function that has 3 x-intercepts and goes through that checkpoint. Plug that point in for x and y to find your stretch factor.